Hello again and welcome back. My name is Tom Nelson and this is video lesson number 10, step number 4 of the 6 steps to gaining complete control over diabetes. And this is part 2. We're talking about exercise. So we're going to go through a metabolic contrast. You're going to learn how your metabolism works. In the center of your brain is a small organ. It's called the hypothalamus. I call it the control room, because it controls over 25,000 different functions throughout your entire body. The personnel, as I call them, they're imaginary little workers in there, they're in your control room. They watch everything you do, and they look for patterns, and they make adjustments accordingly. So next, we're going to compare how this works with two extreme opposites, an Olympic athlete and a couch potato. Okay, we're going to do a metabolic contrast between a couch potato and Olympic athlete. For the couch potato, they have low cellular oxygen capacity, they have low vascular oxygen capacity, they have a very low lung capacity. The size of their lungs are significantly smaller. They have very few capillary vessels on the heart to pick up oxygen. They have a weak heart and they have very weak lung muscles, and they have very weak body muscles. They have very few capillaries on their lungs to pick up oxygen. They burn less fat, and they have a lower T4 conversion. That means whenever your mitochondria, your power plants, fire, it's a T3, it's a thyroid hormone that causes that combustion to take place to produce the energy and the heat. Well, T3 and T4 are produced in your thyroid gland. And the T3, which is only 6% of that total production, is the active form. That's the one that's going to be needed to light those fires in those power plants. So if you become active and if you need the extra, then the T4, which is the reserve form of that thyroid hormone, can be converted into a T3 so that more of those fires can be lit and more energy and heat produced. But when someone is a couch potato, they're not burning very much energy, so they're not going to convert very many of those T4 reserves into T3. Instead, they're going to be converted into something called reverse T3 by hormones, which is going to make them completely useless so that you really can't use them to produce energy. So this person's also going to have elevated blood pressure, and they're also going to have elevated cholesterol. So let's take a look at what happens here. Let's say, for example, this individual ran out of beer and his snacks. So he decided to get up and go to the kitchen and to get some more. And this will be a little bit of an exaggeration, but not too far off. This person then stands up, and he has to stop and lean on the couch for a moment because he has almost worn himself out just standing up. His muscles have used what very little energy was stored in the cells. And so consequently, since there's very little additional supplies in the cell or in the vascular system, then the little guy in the control room, realizing that something's going to have to be done very fast, increases his heart rate and his respiration, his breathing. So he may be a little out of breath. He'll be breathing more rapidly because his body, the little guy in the control room, is frantically trying to get more T3, more vitamins and minerals, more glucose, more oxygen, and all of the other constituents that are needed to produce that energy has to be restored in the cell in order for him to be able to use it. And so it takes a second or so at that elevated rate for the blood to be moved to those muscle cells to restore what was used when he stood up. So now he's going to struggle to the kitchen, and he'll have to lean on the refrigerator for a minute to get his breath. He'll open the refrigerator and discover that there's no more beer in the refrigerator. So he'll work his way out into the garage, get another case of beer, carry it in and set it down, and he'll have to rest once again. So he'll stock the refrigerator, he'll get his beer, he'll work his way back to the couch, and he'll be very relieved to have finished that very exhausting task. And it's all because the little guy in his control room has studied his routine and has realized he's not going anywhere very much, very often, and so he doesn't need all of those power plants. He doesn't need excess glucose, oxygen, or T3s, or any of the other constituents that are needed to produce energy because he just doesn't use it. So Now we're going to do a contrast with an Olympic athlete. This person is going to have a very large cellular oxygen capacity. That means lots of oxygen is going to be stored, not only in the cell, but in the vascular system as well. This person is going to have a much larger set of lungs and vascular capacity as well. He's going to have a much stronger heart muscle, stronger lung muscle. He's going to have many, many more mitochondria, those power plants, in each of those muscle cells. So his heart and his lung is going to be equipped so that it can very quickly respond to demands for energy, for oxygen, and for all the constituents that are involved in producing it. So this person's going to have very highly developed muscles. They're going to have massive capillary blood vessels beds on their lungs. They're going to have very low body fat. They're going to convert a massive number of those T4 reserves into T3s, and it's going to be really keeping things going. Those power plants are going to be going like crazy. And this person's going to have low blood pressure and low cholesterol. So let's take this example and look at it closer. Let's say this person realizes they've run out of their energy drink. And so they are capable of doing a backflip over the couch and continuing backflips all the way out to the kitchen, to the refrigerator. And as they open the refrigerator, their heart level rate and their respiration rate has hardly changed at all. They're still pretty much almost like they were at rest. Well, then they discover that there are no more energy drinks in the refrigerator. So this person, theoretically, exaggerating a little, is capable of picking up that refrigerator and carrying it out to the garage, restocking it, and carrying it back and replacing it. And still, their system will not be taxed very much at all. Their respiration rate and their heart rate is going to be only slightly elevated. So why is that? Because this person has been observed by the little guy in the control room while he goes to the gym every day of the week for as much as 16 hours a day and is pushing himself to the limit. And the requirements on his cells of the muscles is very extreme, and his lungs and his heart and his entire body, because he's been forcing his body to produce as much energy as needed in order to support his lifestyle. So it's his lifestyle that makes the difference. If you become a couch potato, the same thing will happen to you as did this couch potato. If you exercise and you get all kinds of vigorous activity in your life, things will be changed by the little guys in the control room in order to accommodate that, to make it possible. So you can see how you control your metabolism. You control all of these things just by what you do each and every day. So let's now consider this in a third scenario. Let's assume that this athlete suffered a very serious major injury and that they're forced to stop their training altogether and they're totally incapacitated. So that person is going to be sitting quietly day after day, and it won't take very long for the personnel in the control room to realize something has changed. And so they realize this person isn't going to the gym anymore for 16 hours a day. And consequently, they're going to start shutting down all of those power plants. They're going to reduce the amount of oxygen and glycogen that's stored in each of the muscle cells. The lungs and the heart muscles will begin to lose strength and capacity. And the muscles will quickly lose strength and volume, and they will slowly but certainly start to approach the couch potato status, just because they have changed their routine. So I hope this illustrates for you how you can control your health and your body's function. So now proceed to lesson number 10, part 3, types of exercise. Thank you for taking the time to watch this video, and please pay it forward. Share what you learned with others. Thank you.